Welcome back to my YouTube channel. Today I will be discussing a question on the linear algebra topic of the JAM exam. Okay. So question is given that T R2 to R2 be a linear transformation by defined by Txy equal to minus x comma y. Okay. Then the which of the following is true. Okay. Now solution. Here given the transformation T from R2 to R2 and defined by T of xy equal to minus x comma y. Okay. Now we operate T again on the both side. Okay. So we have T square, that is xy, this equal to T minus x comma y. Okay, so this equal to x comma y. Okay, now again operate T both side. So TQ, that is equal to x comma y, this equal to T minus x comma y. This is equal to, so this equal to x comma y, and this is equal to minus x comma y, that is equal to T. Okay, now again we operate T again in both side. So T to the power 4 x comma y, that is equal to T minus x comma y, that is equal to x comma y. Okay, and again we have T to the power 5, that is equal to x comma y, this equal to T of x comma y, this equal to minus x comma y, this equal to T. So here we observe that when power of T is even, so this is not equal to T or not equal to minus T also. Okay, but when power of the T is odd number, so this equal to T. Okay, so first option is false. Okay, because T to the power 2k, 2k always even number. Okay, so this is a false option, and similarly option number B is false because 2k plus 1 is a odd number. And here we observe that when T to the power odd numbers, so this equal to T. Okay, not minus T. Okay, so option number B is also false. Now option number C say that the range of the T square is the proper subset of the range of the T. Next we find the range of T. Okay, if x greater than 0 and y is arbitrary numbers, real numbers. Okay, now T of x comma y, that is equal to minus x comma y. Okay, so this, if x is greater than 0, then x is negative in range. So this is equal to set of all point, the range of this number x comma y. So where x greater than 0, this equal to, so this is equal to s. Okay, this set. So s equal to T of s. This is equal to set of all x comma y such that x less than 0 and y belongs to R, arbitrary. Okay, and this is s1. Okay, now s2 equal to set of all point x less than equal to 0 and y belongs to arbitrary. Okay, so this set, range of this set equal to x comma y, that is equal to minus x comma y. Okay, if we know that if x less than equal to 0, so minus x greater than equal to 0. Okay, so range set of S2, this equal to set of all points x comma y belongs to R2. Okay, such that x greater than equal to 0 and y belongs to R. Okay, so here S1 union S2, this is equal to R2. Okay, clearly see. Okay, so this implies the range of R2, this is equal to set of all point x comma y belongs to R2. Okay, that is equal to R2. Okay, set of all points. Okay, now now x2, now t square x comma y equal to x comma y. Okay, so here x comma y is arbitrary point. Okay, so this is identity operator t square, so range of t square, this is equal to R2. Clearly here range of t equal to range of t square. Okay, so option number C is incorrect because not proper subset, this is equal, so option number D is correct option. Okay, answer of the question is 3.